Hi everyone, I'm Tariq. I'm Chief Architect at Codasip. I've spent something like 4 years looking at CHERI now, last probably 2 years very intensely, and talk about RISC-V standardization. So I've spent, I think, 7 years working on RISC-V now. It's been quite a while. If you look in the RISC-V unprivileged manual, the code size reduction chapter was written by me, for example. And I've contributed to numerous other extensions as well. So, just under 2 years ago, we started working with Peter and John and Alexandra and others who I'm now looking at from the RISC-V event in Barcelona. We started working on how we transition from sort of the CHERI v9 spec into something that we could actually try and turn into a product and standardize for RISC-V. So as a result, partially we have the demo of the CPU out in the hall, running Doom under Linux, so the hardware of that. But also, we now have the first version of the specification integrated into the unpriv and privileged documents of RISC-V. So Alex Richardson has been doing the privileged, I've been doing the unprivileged. It's taken many of my waking hours in the last week to get that integrated, but it's there and under review. So, as a slight recap, RISC-V currently has 5 base architectures, the choice being 32 or 64-bit, 16 or 32 registers. There's also the outlier, RV128, which nobody really cares about. But the idea is that CHERI becomes 2 new base architectures, either 32 or the 64-bit. So the idea is you sort of automatically, you import instructions from one of the others, and then, but what we do with them basically is up to us from that point. So if you're RV64 CHER, I suppose, then you get everything from RV64I or RV64E, and then you use it as you see fit. So our current spec is 0.9.5. The document's quite long. We put instruction pages in, which we're taking out because RISC-V doesn't have instruction pages generally, which has made the document quite a lot shorter, unfortunately. And yeah, we've been splitting it into different features. So the unpriv, say I've been working on. The privileged has been split into the machine mode and S mode, which Alex has been doing, which I haven't had a chance to read. And we also need to add to the debug spec, so that's SD CHERI. All the names are initial, but they gave us the RV32 CHER name, RV64 CHER name. So we're a separate base architecture. That means we can basically do what we like in different places. So one of the least popular things about RISC-V is the fact that the 16-bit encodings take up a lot of encoding space, and most of them are wasted on floating point load and store instructions, which nobody cares about. So for CHERI, we can reuse them and do something useful instead. So this is actually quite a big advantage. So we have the load cap, store cap, and stack pointer relative instead. Close to the microphone. Oh, sorry, the microphone's there. Right, yeah, sorry. Okay, so unprivileged architecture defines the pure capability machine. We define that first, and we define the hybrid mode later. So we start off with 32 registers, which are now C-len wide, so double X-len, and we list all the instructions in the base architecture. So we add things like load capability, store capability, and the capability manipulation instructions. And the unpriv section has the application program as view, so it should just be what an application programmer needs to know and nothing else. The hybrid features are in a different chapter later on, where we add in DDC for authorizing integer mode load store accesses and the mode switch instructions. So in the privileged architecture, so we add in extra bits into lots of the system CSRs, so CFG, CFG, and such like. We extend the virtual memory, so we have the extra 2 bits in the PTE, CW to restrict capability rights, and the user mode capability regeneration, which I think Alex has renamed to SV CHERI in the latest version. And we add in CHERI exception handling and exception types and such like. So what else? So the encoding format needs to be separated out, so it's currently in the appendix. So this can be replaced for the Chariot version, very important. And I've changed at least some of the text to be more generic. So previously CAD talked about representability check, and I've changed that to steal Chariot's wording and say whether the result can be represented exactly. So there you go. Obviously, I guess we'll get through the standardization part for this first, and then you can add a Chariot chapter later. That'll be exciting. And another note that we need to update the debug mode as well. So that's it. Oh, I've come in under time. So there you go. Thanks to people who've helped write the spec and people who've been reviewing it. And I think that's it. There you go. I've got 3.5 minutes. Shall I take questions?
Absolutely, take questions. Yeah.
If there are any. Oh, hi.
Yeah, you mentioned that RV32 and
Yeah, we need a better way of saying that.
have 32 registers. Do you also have a 16 register variant of it?
Well, I think it's sort of implicit, because in the other extensions, I mean, RV32E just sort of inherits from RV32I, but changes the number of registers. So I suppose maybe we need to explicitly list that. I mean, I don't see why not. We just haven't explicitly written that down. There's no reason not to.
Yeah.
So, but yeah, I guess that should be formally added in at some point.
Yeah, so you should have, you're thinking you should have an option between 16 and 32.
I think so, yeah. Yeah, I think so. And I guess that means maybe we need another letter, so ICH and ECH, maybe. I don't know. I don't choose the names. They get inflicted upon us. Okay. Anyone else? Oh, hi.
So how would this work with, say, some of the extensions that might need access to memory? So if you had an extension that needed to access memory, could that extension be also CHERI enabled? Or?
Yeah, it should be. The way we've done it is we write the rules for accessing memory, and then all load stores and atomics need to follow those rules. So everything that accesses memory uses RS1 as the base register, and so that changes to CS1. It's in the capability source, and then you follow the standard rules we've written down. So we shouldn't need to say anything about most of the extensions. You just say that you use the capability instead. That's the idea. Oh, hi.
Thanks. Did you find the worldwide RISC-V community was very supportive of CHERI in general, or are they a bit suspicious?
That's a good question. It's interesting how you're further away and yet your voice is louder. I'd say that we've been trying to... It's taken us quite a while to get to this point within RISC-V. I think that people have been sort of suspicious of it. I think the thing that people really don't like is doubling the size of the register file, especially in larger out-of-order machines where it is a high cost. So I think an important thing that we need to do is make sure we're really making use of those double-sized registers. So for stacking 2 integer registers into a single one, for example, to reduce register spills is one example. But I think other than that, I guess the tagged memory, but people are more used to that now because of MTE from ARM. So I think the resistance to that has dropped. But yeah, I think it's doubling the register file state. It's been very unpopular. But eventually people are going to have to give in and add security into their product. So it's the obvious answer. So that's it. Thank you.